Hi, folks. I want you to just do the best you can, okay? I mentioned in my test correction video, sometimes we're really hard on ourselves. This could be one of those situations when I look at this section, it's a challenge. This is section 7.2. There's a lot of information in there. I'm going to try to break it down and make it as simple as possible, but I do want to remind you that there is a textbook that we can refer to. And so when we look at that textbook, it's over. Where the heck did it go? There's my picture of where I got the image of the die that we're going to talk about. So I took a picture from, section 7.2 right here in our textbook of example one. And I'm going to try to use example one to make the concepts clear. There are more examples though. And I see some of you guys, refer to the slide deck and find information. And that's great. That, you know what? Those people have a big growth mindset. Like I might get stuck watching the video. I'm not sure exactly how to do a particular problem. So I'm going to look in the book, or I'm going to call Mr. Nelson over and ask for help. That's what I expect you doing. All right. So thank you. Here comes example one. Set up your notes like this. We're going to be able to find or use the concept of intersection and union of two events occurring to determine the number of elements or outcomes, okay, or items in a situation, okay? So this word element sometimes kind of throws people off. We're trying to count how many different ways something could occur, okay, or occurrences. I can determine the probability of an event occurring. Now, we're going to practice that a bunch, and if today you walk out of class feeling like I got it, fantastic. If you don't, I want you to be patient with yourself. So let's get going, okay? Let's keep this as simple as possible. Let's say you had one die. You're going to roll that die. There's 6 sides on the dice, right? And they're numbered 1 through 6. 1, 2. I'm not trying to insult anybody's intelligence, but let's just list out all the different items in our set, or these are elements in our set. 1, 2, 3, 4, 5, 6. Now, if we want to make it look like a list, we'd put little curly brackets around it. Okay, so that's what happens when we roll a die. We can get any one of those numbers, right? So they often will talk about events occurring. Okay, so here's event A, and I would suggest you pull out a highlighter and maybe write down, event A, and highlight it in yellow, and event B, highlight it in blue. And what is event A? We're rolling an odd number. So again, back from like section 1, counting how many elements is really important. And so let's just make a list of these elements that are odd numbers. Well, odd numbers are, not divisible by 2. So 1, 3, and 5. Okay. There are my odd numbers. I'm going to go to event B. Why don't you put the video on pause? You list event B. All right. Welcome back. It says the event of rolling a number greater than 3, greater than 3. So that doesn't include 3. If it would have said greater than or equal to 3, then I'd include 3, but I'm not going to include 3 because it says greater than 3. So I'm going to put down 4, 5, and 6. Okay. So there are 3 elements up here, 3 elements or 3 items. I'm going to use the word item for a second. 3 items here, and there are 3 items down here. Okay. And there's 1 item in common, or 1 element in common. Oh boy, is it okay if I go back to the word element? 1 element, they're the same, they're interchangeable, they're synonyms. Okay, they're the same concept. So items, elements. Okay, so there's 1 element in common between the 2 different sets, right? And that item that's in common is the number 5. See the number 5 right there? Let me circle that guy right there. The number 5 is the one that's in common between the 2 sets. So when they ask for intersection, they might use a fancy set notation symbol that looks like this. This is the symbol for intersection. So if we want the intersection of A and B, we're going to see this symbol, A intersect B. We're going to see this key word right here, and. Okay, so when you see the word and, you think, hopefully you're going to think intersection. And we want to know, what are the elements in common between the 2 sets? What do they have in common? Well, they have 1 element in common. So if I was going to list A intersect B, that is the number 5 only. Okay, and I mean the item number, the 5, right? I don't mean 5 elements. There's 1 element here that has the number that's in common between the two sets. Okay, so that's my intersection. If they ask for union, you're going to see the same exact phrase. Let me see if I can do a copy paste here. Okay, so give me one moment here. So I'm going to take example one. I'm going to do a Control C, Control V, paste it. I'm going to get a copy down here, but I'm going to change it to a union problem. Okay, so here's how it would change and be a union problem. So what I'm going to do is I'm going to cross off like example one. I'm going to call it 1B, modified here, modified. Okay, how would it be modified? It would have the word or right here. Now, I know it doesn't seem like a big deal, but if it said, let A be the event of rolling an odd number, or and B, so it wouldn't say, let me back that up for just a second. It doesn't make sense to change the word and right there. And let B be the event of rolling greater than 3, and then they won't have this symbol right here. They'll have this symbol right here. So they might say event A, if it was in written, English, event A or event B. Okay, that means that we want union. So how do you find union? Well, A union B as a set of numbers would be 1, 3, and 5. Okay, so I'd go 1, 3, and 5. Now, I don't need to list 5 again. I just need to add the numbers that I have not already listed from event A. So these are like the numbers from event A. Now I want to list the numbers from event B, and I don't want any repeats. So I'm not going to put 5 down again. I'm going to put 4 and 6. Okay, so let's think about that for a second. How many elements do we have? We have 1, 2, 3, 4, 5. Okay, so we have 5 elements. 5 elements. And, if we would have just taken this 3 items here, like from A and B, if we would have taken A's 3 items, and B's 3 items, and added them together, that would give us a total of 6 items. But the 5 would get counted twice if we did that. I want you to imagine if I did repeat the 5 in here, you'd have 1, 3, 5, 5, 4, 6, or put the 5 between the 4 and the 6, whatever, doesn't matter. You'd have 6 elements, 1, 2, 3, 4, 5, 6. But do you notice the 5 gets counted twice right there? The 5 gets counted twice. So when you're doing A union B, you can take the 3 items and the 3 items, add them together. So that gave me the 6 right there. That's the 3 plus the 3. But what you also need to do is you need to subtract how many items are in the intersection. So the answer for the intersection question was there's 1 item in common. That's also known as the intersection. 1 element in the intersection. And so I'm going to subtract 1 from my 6 number, and that gives me 5. Now, I know what you might be thinking. Nelson, this problem's not that complicated, man. You don't need to go 3 plus 3, get 6, and then subtract 1 from it. I can just see there's 1, 2, 3, 4, 5. I'm not going to count the 5 number twice. Of course, I wouldn't do that. But in more complicated situations where you don't want to write all this down, remember, we're starting with real simple sets here, simple examples. And in more complicated ones, you're not going to want to write them all down. So you want a rule to follow. And that would be count the items in A, count the items in B, add them together, and subtract the intersection. Okay? So they give us some fancy notation. It looks like this. The number of items in A plus the number of items in B, and you're going to subtract the number of items in A intersect B. Now that looks really like fancy notation, but this is the little rule that you could follow if you understand what all the notation's about. Okay? This is how you find A union B. How many items are in A union B? The number in A union B. Okay, that's what the N stands for, the number. So we're getting down to probability. This is what we're going to be trying to do. We're going to be trying to calculate a probability, not just count up how many items are in a set. So how do you do probability? Okay, so that's what our focus is here in the next few minutes. All right. So I just want to turn to the page in the textbook where they talk a little bit about probability and a rule. I want to get to the correct page. And it is on page 374. 374. So they switch notation and they say something like this. What is the probability? So they put a P down and then they put parentheses down. And I'm going to do A intersect B, and I'm going to do the probability of A union B. Before I do each one of these probabilities, I want you to think about which one do you think is more likely? The probability of A intersect B, that was getting a 5. Or do you think the probability of A union B would be more likely? That's the probability of getting a 1, 3, 5, 4, or 6. We'll take 1, 3, 5, 4, or 6, and we'll be a winner. Or we got to get to number 5. Well, of course, you're thinking, hey, this probability down here is going to be larger. The probability of A union B is going to be larger than the probability of A intersect B, because I've got 1, 2, 3, 4, 5 numbers I'll take. Up here, I only will take one number. So let's see how that works. How do you calculate the probability now that we can count up the sets? Well, what you do is you take the probability of the number of items in the outcome. So the items in the outcome, the number of items in, the way they put it, in the outcome of A union B, or if you're going to do the intersection, or you do A intersect B, and you divide that by, the total number of outcomes. Total number of outcomes in general, like of rolling the dice. I'm going to put down in general. And they say the total possible outcomes. I kind of like that too. So that's the way I've said it in the past. So the number of outcomes, total possible outcomes. I'm gonna erase this outcomes over here too and put down number of total possible outcomes. Total possible outcomes. Okay. Now, let's do that right here, and then we'll do the A union or the A intersect B one. So A union B, son of a biscuit. All of this stuff, if you want to fix your notes here real quick, we're going to move that down. Let me try again here. I want to take all of this because let me fix it this way. I'm going to do A, because I want to keep it with this guy right here, right? I'm going to do A intersect B up here, and then I'll do A union B down here. All right, so let's do it that way. Sorry, I wrote the wrong symbol there. The number of items in the outcome of A intersect B is going to be this one, okay? And A union B will be this one right down here. So once we get the total number of items, we're going to, that'd be our total possible outcomes. We're going to take total possible in the denominator, okay? And up in the numerator, we're going to take the number of items in outcome of A union B. Okay, so what did we determine up here? The intersection up here was, there were, let's see, one element in the intersection. It was the number 5. So I'm going to put 1 right up here. Now, how many items can come out? This is the total possible right over here. Total possible. Shoot, I keep forgetting the other S. Possible. That's 6 items. There's 6 different numbers that could come out if we roll the die. So I put a 6 down in the denominator. So I get 1 out of 6. What's the probability of getting A union B? Well, A union B was 1, 3, 5, 4, or 6. That's a total of 5 elements. So I put how many elements up in the numerator that I want, and I divide it by the total number of elements that could come out if I roll the die, and that's 6. So this one's 5, 6. This one's 1, 6. So let's jam over to Desmos real quick, and we're going to try to change it to a percent just for exercise sake. Shoot, where'd my Desmos go? No, that's not it. Here we go, Desmos. So I'm going to go 1 out of 6, and I round to 2 decimal places if I want a percent. So I'm going to put down 17% or 0.16, right? So this right here is approximately, or 0.17, right? Didn't I say 0.17? Yeah, I'm rounding to 2 decimal places. So 0.17 or about 17%. So if you want to convert it to percent. And then this one down here, I want to go 5 out of 6. So let's put down a 5 in the numerator. Okay, so 5 out of 6 would be 83%. Well, that kind of makes sense because the two together, let's put down 83%, 0.83. That's 83%. Okay, because you can see this one's 1 6, this one's 5 6. So they add up to be 6 6, if you will. So this, 17%, 83% add up to 100% in this situation. So I hope I'm making this clear about probability. You want your favorable items, like the number of outcomes in the situation in the numerator. You want the total possible outcomes in the denominator. And you can see we had 6 for the die because there's 6 sides to the die up here. All right. I hope you got some solid notes and you can try some of the homework. Call me over if you're getting stuck on the homework. Thanks for watching the video.